All right, so I'm going to describe the transformations of this function. This is like the first 6 problems on your homework. You're just looking at the transformations and describing them. So we're not talking about the algebra we would do to like plot the points, just visually what's happening to the graph. So let's start with under the square root. We've got 2x minus 5. Now keep in mind, everything under the square root is happening horizontally. Right? All transformations inside the function are always horizontal transformations. Now, when we did log functions, that was inside the log. When we did exponential functions, it was whatever was in the exponent. Now that we're doing square root functions, it's whatever under the square root. Okay? So then, if we look at that, we'll take a look at our 5 first, because we'll do this in the same order that we would if we were actually graphing it. Remember, with horizontal transformations, you do opposite order of operations and opposite operation. So the first thing, algebraically, we would be adding 5 to all of our x's. Well, that's going to be a horizontal shift, because we're shifting it around. Horizontal shift, but since we're adding, it's going to go to the right. Horizontal shift to the right, 5 units. Okay. The next thing we would do is algebraically we would divide by 2. It says multiply by 2. We do the opposite. We divide by 2. If you were to take it and divide it by 2, you obviously can't see me right now, but like an accordion, right, if we stretch it, if we multiply it out, it stretches. If we divide it, they're going to get closer together. So it's going to be a horizontal compression. So we'll have a horizontal compression. And even though we're dividing and it's getting smaller, it's by a factor of 2. So we'll say horizontal compression by a factor of 2. Okay, so that's it for our horizontal transformations. That's all that's happening under the radical there. Now, outside the radical, we have -3 and +1. Let me pick a different color. -3 and +1, right? The -3 is being multiplied and the 1 is being added. Remember, with vertical transformations, we do as it says. We follow order of operations and we do the operation given. The only thing is that when we multiply by -3, 2 things are going to happen. 2 transformations happen from that one algebraic action, right? The first thing is if we're multiplying it by 3, everything's tripling, so it's stretching. So first we'll have a vertical stretch by 3. And then that negative, multiplying everything by a negative, it flips its sign, so it's going to flip the orientation of the function. It's vertically flipping it. So you can either call this a vertical reflection, okay, a vertical reflection because the negative is on the outside, or think of it, it's going from, if it was up and it's being vertically reflected, now it's going down. It's kind of counterintuitive, but that's going to be over the x-axis. So we could also call this a reflection over the x-axis. Those are the same thing. Okay, then the +1, we're adding 1 on the outside, so we do what it says. Adding 1 to the y values, it's not going to stretch it out or change the function at all, right? It's kind of like a translation in geometry. It's a rigid motion. The function, the curve doesn't change at all, just where it's located on the grid changes. It's going to go up 1, so we will call that a vertical shift up 1. Okay, now this is all you do for describing the transformations, right? We're not actually graphing it, we're just describing the transformations here. Had we been graphing this, just for funsies, if we were actually going to graph this, right, we would do the horizontal shift and the vertical stretch and reflection first. And the horizontal shift, we would do x plus 5. The vertical stretch and the reflection, we would do y times -3, right, to our parent function points. Then secondly, we would do our horizontal compression and our vertical shift. For the horizontal compression, we would divide our x's by 2 And then for the vertical shift up, we would add 1 to our y's. Okay, so that's not part of this question, but when you get to the graphing questions, that's what you'll actually be doing.